ideas?
What was the question?
Well, okay, let me ask you this. So this was this red parabola, this is my parent function, right? And then the blue parabola is like if I took this red one and I added 3. I have that x squared and I add 3. What am I adding 3 to?
The y.
Not the y-axis, but the y values, right? So what is adding a number to the y values do to the graph?
Makes it go up 3.
Okay, it makes it go up. So that's what happened from basically red to blues, it went up. What did you notice happened if you subtracted a number from your y values?
It goes down.
Okay, the graph went down. Okay, and then, also, so since we're talking about translations like we said earlier, and this one's moving up and down, what could we call this kind of translation? What word describes the movement up and down?
Vertical.
Vertical. So these are what kind of translations? Vertical translations. Okay, so moving on from this point forward, if you're talking about or if you're talking about a translation of a graph or of a function or anything like that, you know how to describe it. So then, what about this transformation? So the red parent function, kind of like when you had the bell ringer, like if this was like my pre-image and this was my image, what changed about it when I added 3? What am I adding 3 to?
The x.
Okay, am I adding 3 to the x values or to the y values here?
The y. Oh wait, there's one.
So I'm adding 3 to the x values here, and then how does that change it, Jacob? So if this was my original, and I added 3, if my, let's see, the vertex was on 0, 0, and when I added 3 to the x values, it's now at negative 3, 0. Yes, and say that again. So, right, so kind of like, when I added 3, what direction did I move on the graph? To the left. Yes, it is. We're moving horizontal when we change the x values. But notice how, remember when we had the forms of the quadratic equations and you had your vertex form and it had that f of x equals x minus h squared? Right, so when this was in vertex form and I had the x minus h here, what did that minus h signify for what the point of that vertex was? Right, but what did we have to do because this was a minus? What did we have to do? Right, you had to do the opposite because it was on the inside of the parentheses, right? Okay, so we have a similar idea here. Okay, so now, if you haven't looked at this question yet, go ahead and go to that page 3, I believe. It says, okay, so we've explored 2 transformations. What 2 transformations have we explored? That's not the transformation, though. Vertical, horizontal, what? Not what kind of translations, right? So these are strictly translations. So the question says, how does the location of the addition and subtraction in relation to the function's main operation? So in this case, we're talking about the square because our function was f of x equals x squared. So saying how does adding or subtracting a value change the direction of the transformation on a graph? Okay, so I want you guys to take a few minutes in your group and talk about this, and we'll come back and discuss. Like 2 minutes, get your ideas, and then we're coming back. Good.
One thing to clarify, if you look at your slides, think about where that C is on the Desmos slides. Isn't that what you're referring to?
Yeah, so when we had, so this C would be on, we could say the outside of it's on the outside of the main operation, so when it was on the outside, what happened? with the graph. And then think about what happened when you added a value to the inside of the main operation. Does that make sense, guys? Okay, y'all think about that. So you should be talking about two different scenarios and writing about two different cases for this main idea.
It talks about, in this case, the square, there's the square, right? And so how does the plus c outside of that square affect the function versus, if you look at slide 5, where's the c there? Side. So how does the plus c outside the square affect the function versus the plus c inside the square affect the function? Get your hands out of your pockets. It's hard to write stuff down and think and learn.
By adding the vertical translation, and then if it's on the inside, okay.
We got something, but I'm not writing it down.
You got a lot of space there. Write it down. Take pictures of the meetings. What's your idea?
I'm not gonna.
No, then there's no evidence.
Okay. I'm just writing it right now.
No, that's silly. You learn when you make mistakes.
But I don't like erasing it, or it's gonna give me another sheet.
You could split it in half.
But when you move the C positive, it's up to the left side.
Okay, but look at the question, right?
But be
That
more
is part of
specific, like
How
what
does the
increases
location
and
of
what
the addition or
decreases.
subtraction in relation to the function's main
Like instead of saying
operation?
it, what are you referring to when you say
Okay,
it?
so
The C.
here's slide
So,
5, that
yes.
was slide 3
It's
maybe?
over.
When this is.
But also talk about how the graph moves
Where
on the
is C
thing,
in
on
slide
the
3?
plane.
Is the C in slide 3?
Okay guys, if you finish that question, start looking at the application question. It's pretty straightforward. Just practice using
Affects
some
the
good
Y,
mathematical
not axis, 'cause
reasoning.
the y-axis doesn't move, it affects the y values. But that's not what I asked.
You want to talk about, you know,
Where is
what's
the
going on in
C
the
in
graph,
respect
what's
to the
going on in the
square?
table, stuff like that.
Will it be full?
No. In the equation, I'm not asking you to look at the graph, just look at the equation. Where is the C? Right there. But remember, we said in respect to the main operation. The main operation, what's defining the shape of that graph? What is the shape of that graph? Okay, there is a square there, but what's the shape of that graph? That's exactly the question I asked. We have told you about this. What is a concave
Let's see.
parabola? Thank you. What makes a graph a parabola? The Look at the equation, what in the equation makes the shape a parabola? You said it earlier, Jacob.
I did.
Yeah. The red is also parabola, there's no C there.
What did I say?
Look at the equation, what makes that function quadratic, which is what makes the graph a parabola?
Oh. What I say?
You can't see a vertex in this
Okay.
equation.
Or
Look, just,
square.
thank you, doesn't a square make it a parabola?
I said square though, just not,
How
you
did
can't
that
say
include
push.
that in there?
And you remember when I said, you said it earlier?
Wait, what?
Uh-huh,
With a square.
the square is what makes it a parabola.
Alright, well, he says it moves the vertex up, but
We're literally
is the
looking
vertex
at
the
it for
only
first
point
time
of that shape, of
45
that
minutes
graph?
today. Compared, so like, we're exploring it, but
So how do
the
those points
question.
change? What's
it comes
changing?
down to, this is what you need to recognize, the shape of this graph is a parabola, right?
So if I
So what
have,
is the
if I
main
have a
operation for
point
this
that's like
function? It is
0,
the
0,
square.
and I move it 12 points
So when the
up,
plus C
12
is
units up, is my
outside
new
of the
point
square,
right?
how does it change the function?
Depends now.
If I move it 12
Can I
units up,
delete it and add it back?
is
Oh.
my new point gonna be 12 12?
No.
What's it gonna be?
Yeah, because you didn't know what the main
So what
operation was.
She's moving it up and down.
Okay, so when the C is outside the square,
Oh.
it's translating up and down. Go to slide 5.
Alright guys, let's start talking about this main idea.
Vertical and horizontal.
So when is it vertical, when is it horizontal?
When it's horizontal and
So I just split this section up.
Pay attention, make sure we have our answers right.
So I just split this section up into two because we're talking, like I said, we're talking about the two cases here. So what happens if the addition or subtraction is on the outside of the function's main operation?
It's a y-intercept.
No,
move up and down.
not a y-intercept, but,
Vertical translation.
right, so you could say,
It ain't no y-intercept
well, Anthony, what's a y-intercept?
when it crosses the y-axis.
Okay,
Look, one thing to clarify is that C does become the y-intercept for now because we're only looking at a vertical translation. What happens when you add the horizontal with the vertical? Then it's no longer the y-intercept.
Okay.
yeah, so what I'm saying is, it won't, right now it's the y-intercept, but it won't always be the y-intercept. So we can't use C, we can't associate the letter C with being a relation to the y-intercept like we did with our forms of quadratic equations.
That is a good clarification too.
You know what I'm, y'all know, because remember for standard form, ax squared gives bx plus c, the c, we always referred to the y value of the y-intercept, right? We're not doing that here. C just stands for the number, well, for today for translation, C was referring to the number of spots or units that the function was moving on the graph, right? So if it's on the outside of the main operation, then what kind of translation did we have, Jakila? Right, so we had a vertical translation so if I added C, which way did my graph move?
Oh.
So you might make some kind of note about that, the graph translated up. Or also, what changed when we added C? Anthony was just kind of talking about it.
Huh?
Right.
So,
The y,
Right.
right, the y values, the graph, the graph translates up,
The Y value changes.
y values change. Okay, so then what happened, or I'll lay all right for a second. Okay, so start thinking about what we're gonna write for when the operations on the ends, or the addition subtractions on the inside of the main operation. And notice, guys, how I wrote x minus c here. Okay, so what is that x minus c gonna do? It's gonna move it horizontally. What if this c is a positive number? Which way is it gonna move it?
Go to the right.
To the right. Okay?
You do?
Well, if I replace, so if this is x minus c, and I replace it with like a 2. Right, so what did that mean when we were talking about the vertex and vertex form? What did you have to do?
Flip it.
Right,
Oh.
remember it's the
okay.
opposite. So here what we're going to say, if the operation's on the inside,
It's a horizontal translation.
right, horizontal translation. And
So when C is negative, it goes up. I mean, it goes to the right. And when C is positive, it goes to the left.
when C,
It might be more clean to think about it as when subtracting C versus adding C.
So when you subtract C, it goes to the right.
let's look at this example. So if I had x minus 2 squared and my parent function was x squared,
It goes to the right.
wait, yeah, so this would go to the right. Is that what you were asking the whole time?
Yeah.
Okay, sorry.
It'll be 2.
So you also maybe be a good idea to put some examples on this section. So you could say this would translate to the right horizontally.
So it'll be 2.
Or yeah, 2.
Yeah,
Translate
'cause
2 to the right. That's what I'm
Negative
saying.
times, negative 2 times negative 2 is,
Hmm.
oh,
We're not multiplying.
because it's squared. So that means a negative times negative is positive.
Yes.
So that.
My x value is not 2 though. I'm just saying this is, if this was my parent, so remember like in the Desmos slides, if I started with x squared and then I subtracted 2 from every x value, what happened with that graph? It would move to the right.
I think Anthony's question is also going back to, you're squaring that negative 2, but remember, that's not negative 2 squared, that's x minus 2 squared, which means x minus 2 times x minus 2. So it's not a 4. Is that what you're thinking about, Anthony?
Oh, so x minus 2 times x minus 2 would be.
You would have to distribute, we'll get into that later. You need to focus on the translation.
Yeah, don't worry about that.
Think about your vertex form, it connects to that.
Yeah, so right now we're just talking about how is this graph different from the original parent function.
So when it's minus, it goes to the right, and when it's added, it goes to the left.
Right. So everybody good on that?
So basically the opposite.
Yep, and similar to how it was when we were talking about vertex form. Because remember, if you had something written like this, if I had x minus 2, what would that vertex be? The
2.
Right, it'd be a positive 2 and a positive 5. Okay, so do y'all see that connection here with how that part stays the same with what we're learning?
Mm-hmm.
Okay,
Just without the A. No,
do what?
Just without the A.
Oh, I'm just using this as an example to show you that use the opposite
Oh, okay.
if it's on the inside of the parentheses. But, okay, so have y'all had a chance to read this application question yet?
No.
Okay, so some people have, some people haven't. Let's just read it together. Jaden thinks that x squared plus 12 will translate the vertex 12 units up, but he's not sure about the rest of the points. So, using precise mathematical language, how can we improve his understanding here?
It's true.
Well, think about, is the vertex the only point that's going to move?
No.
Okay,
The
so
whole
what's
y
moving?
value. The whole Y value.
So if I have this
Why is it
parabola,
gonna move up?
say,
Why is it moving up?
Okay.
Because it's being plus C, right?
right, because it's
It's on
that
the
plus
outside.
12. So this is talking about if the parent function was just f of x equals x squared. Okay, and then we're transforming it by adding 12 to it. What happens?
It go up
By how much?
12.
So is the vertex the only point that's going to go up 12 units?
No, the whole thing will
It's
go
gonna
up.
go up. So the point's gonna change.
What points change?
The Y value.
The y values, not the x values. Because here, so if I was showing somebody this, like if I have this point 1, 1, and I want to translate it 12 units up, is my new point going to be 13, 13?
No, it's gonna be
No.
113.
Why, Anthony?
Because the 12 is the outside unit, and that's Y.
Right, because we're adding 12 to the y values, which causes our vertical translation. Does that make sense?
So the X goes from.
Yeah.
Yes.
When it's not in parentheses, when it's parentheses, the X changes and the Y stays the same though.
Yes. So we will come across, or we'll do some problems later on where you'll have like equations that have two translation or more than one transformation at one time. But right now we're just doing we're just talking about is either a vertical translation or either a horizontal translation. Oh, so for this, I'm gonna skip past this, but if you want to go back to this later, or if you already haven't talked about it with your groups, what's another representation you could use here to support that reasoning? Table. What else?
Graph.
Right, graph. Okay, so this is where we're going to go hop back on Desmos for a second. So if you look at the bottom of that paper, I believe you should see this problem. So far we've only been talking about, or I started this lesson by just using transformations of quadratic functions, because that's what we've been talking about for the last few weeks. And you guys are pretty comfortable with those forms of quadratic equations, and now we can make those connections to how some features of those equations show up on a graph and how those relate to transformations. But so now you guys are going to explore, do transformations only apply to quadratic functions? So so far we use the quadratic function as our parent function, right? The y equals x squared. Okay, so can you guys give me examples of other parent functions that you know? You guys just took a test yesterday on.
Linear, exponential.
Okay, so we've got, we got linear, exponential, other kind of functions. Quadratic. Have y'all seen any other functions in Algebra 1?
Oh, so it's been ago.
Think about, have y'all seen absolute
Oh
value
yeah,
functions?
absolute value.
Cubic. Think about if we have a square. Oh wait, did I even do? Yeah, if we have a quadratic function, then the inverse of that would be the square root function.
Most of that's the Algebra 1B, not 1A.
Oh.
So, okay, so what you're doing is on slide 6, which you have these directions. Sorry, I should have.
What are you trying to do?
Okay, so in your groups, you're going to choose one of those parent functions, and you should be able to. Yes, so when you go on your page is going to look like this. Type in, I'm going to put the parent functions back up. Within your groups, decide on a parent function to use as a group. Enter it into this line 1 that's left blank, and then these will go away when you enter something in. And then use these sliders. So notice how this C constant's being added to the outside of the parentheses, right? So if I change this C, what kind of transformation is going to happen?
The y value can become positive or negative.
Okay, so we might be seeing some changes in the y values. Okay, so I'm going to put these parent functions back up. In your groups, decide on one to test by entering it into that on slide 6, and then answer those questions that follow.
I'm gonna put x squared.
So use a different one than x squared because we've been using x squared all morning, and the question asks, does this only apply to quadratic? So we're wanting to use something other than quadratic to answer this question.
Okay, well, you put x cubed then.
So, I mean, realistically, every group in here could have a different parent function, but you're just,
One clarification, if you want absolute value, I think you have to type in ABS and then parentheses.
oh yeah.
Because I think Allie was talking about that.
Calculator thing.
Oh yeah, or you can use the Desmos keyboard,
That's
has
true.
has
Use
buttons
Desmos.
of those some symbols, there's square root.
We gotta do that here.
Yeah, I just have an
I
idea.
don't even.
Yeah.